wanted to make a quick video regarding the laws of exponents. Again, this is a review video going back to chapter 1. If you'll remember, we did 5 laws of exponents. I'm going to go down the first column and then I'll worry about the second column in a minute, so I don't want you to think I forgot about these examples. I think the first 3 are pretty simple and self-explanatory. 4 and 5 are a little bit trickier. Once I'm done with 4 and 5, I'll go back up and finish these. And then I want to talk about combining like terms at the end, so hopefully I won't forget that. So the first one we have is what happens if we multiply. You'll notice the bases are the same. And again, this is important to understand that the base is going to be this part of it, while the exponent is going to be this part of it. So if we have the same base but different exponents, we're going to be multiplying those together. And the rule is that we can actually add, and here's why. So if I have x to the third times x to the fourth, what it is really saying is I have x times x here, and I'm going to multiply it by x times x times x times x, because this is my x to the third and this is my x to the fourth. So a nice shortcut is I actually have 7 x's. So that would be what we're going to do there. But again, that shortcut is you can just add those exponents together. If you're multiplying these exponents, you can add the exponents together. So that would be 3 plus 4 is 7. Oh, I didn't want to do that here. I'm a little bit worried about using the eraser, because if I use the eraser, I think I'm going to lose my white rectangle there, but I still think I need to do that. Next one is, what if we have x to the m divided by x to the n? So here we have some division. And again, real simple rule here. When in doubt, you can always write it out. I have 10 x's on top, and I have 4 x's on bottom. And these are just going to cancel. Anything divided by itself equals 1. So that's 1 times 1 times 1 times 1, which is obviously 1. And I'm left with 1, 2, 3, 4, 5, 6 x's. But again, you'll notice they point out the shortcut that I can just subtract those exponents. I can subtract 4 from 10 here and get 10 minus 4 is 6. So that is another way. And I think either way, if you want to write it out, that's fine. If you want to use the shortcut, that's fine. Just as long as you understand what we're doing and why. I think that's important. If we get to the next one, we have x to the m to the nth power. What we're going to do is multiply those exponents together. So again, when in doubt, write it out. Here's what that means. That means I have 3 x to the fourth. Right, that's what that third power says. I have 3 of these. And inside of each of these, I have 4 x's. So if you count those out, I have 4, 8, 12 x's. So you can write it out, or you can realize that there's that shortcut that is just 4 times 3. My advice to you would be, as much of a pain as it is, I would write it out. Until you get comfortable with the shortcut. I think if you try and just remember what the shortcut is, but you don't really know why you're using the shortcut's very easy to forget. However, if you understand why you're using the shortcut that you're using, I think you're more likely to remember it. So that would be my advice to you. All right, now we get into a little bit tricky here, this x to the 0 and x to the negative 1. So let's pretend that I had 3 to the first power, and I hope that you all agree that 3 to the first power would equal 3. And if I put 3 to the second power, that would just be 3 times 3, and I would have 9. And if I went 3 to the third power, I would have 3, 9, 27, and so on. 3 to the fourth would equal 81. So every time I go in this direction, I seem to be multiplying by 3. 3, 9, 27, 81. But what I want you to focus on is, what if I come back? I hope you see I'm dividing by 3. 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. So what if I keep going back? 3 divided by 3 is 1. What if I go back even more? 1 divided by 3 is 1 to the third power. 1 over 3 to the first power. I don't know where that came from. If I go back again, what I'm doing is I'm essentially dividing by a third again, right? I'm dividing by 3 again, which is multiplying by a third. So I will get 1 over 3 squared. And if I keep going, 3 to the negative third. Again, what I'm doing here is I'm essentially dividing by another 3. So here I divided by 1 3, here I divided by 2 3s, here I need to divide by another 3. So I need to divide by a third 3, and it's just going to keep going in that direction. And I hope that makes sense to you, that if I were to turn around and head back in the direction that I had started with, sorry, my handwriting is not very clear, that I'm multiplying by 3. I'm multiplying by 3, I'm multiplying by 3, and 3 and 3. So you can see that works. And it's going to be the same if I do it with a 5. And I won't go as far, but I think you'll see the idea that 5 to the first is 5, 5 squared is 25, 5 to the third is 125, and again, in this direction I'm multiplying by 5, in this direction I'm dividing by 5. So if I go 5 to the 0, 5 divided by 5 is 1. If I go to the negative 1, 1 divided by 5 is 1 divided by 1 5. If I go to the negative 2, it's 1 divided by 2 5s, etc. So you can see it's very similar. So what does this all mean? Well, this means that anytime I have anything to the 0 power, it appears to equal 1. And anytime I have anything to a negative power, it appears to be, I flip it across the fraction and turn it positive. So this 3 to the negative 1, remember there's an assumed 1 underneath that. I flip it across the fraction and turn it positive. If it's 5 to the negative third, again, that's supposed to be over 1, I flip it across the fraction and turn it positive. So that's going to be our rule here. So on this one, you can see it's positive on bottom. Well, what that would actually look like is that would have been x to the negative 2 over 1. And again, you don't really need this over 1 part. You can have it if you want. But if you have x to the negative 2, it flips to the bottom and turns positive. And I hope you can see why that works the way it does. So now that we know what happens with the negative exponent, we'll go back up and finish this. So this one would be 2 to the 5th over, well, this 2 to the negative 1 is going to move to the bottom and turn positive. Well, now I have 5 2's on top and 1 2 on bottom. 1, 2, 3, 4, 5. Put my little multiplication signs there. And 1 2 on bottom, those cancel. And I get 2 to the 4th. On this one, again, this one's a little bit easier. I probably can use the shortcut here and just subtract. But I get 1, 2, 3, 4, 5, 6, 7. So we're going to cancel these out. And you can see I get 1 over 5 to the negative third. Although, I'm sorry, it's 1 over 5 to the third. I was wondering what was going on there. Why did I put a negative? I apologize. It's 1 over 5 to the third. Also, you could just get 4 minus 7 is negative 3. However, you want to be real careful because it's not considered simplified if you use a negative exponent. So if you have a negative exponent, you should rewrite it as a fraction with a positive exponent like we did over here. On this one, I'm not going to draw 30 tens, but it's just going to be 5 times 6 is going to be 10 to the 30th. On this one, anything to the 0 power is going to equal 1. And on this one, if we have 3 to the negative 1, it's going to become 1 over 3. Again, it's going to move to the bottom and turn positive. So a lot going on this. I probably should have cleaned this up, but it is review, so I'm hoping you guys recall this. If you don't recall, I will tell you from teaching Integrated 2, I know a lot of kids forget their exponent rules over the years. So maybe some more in-depth look. I just didn't want to make a super long video. I think this video is already longer than I intended it to be. But I did want to talk about one more thing. What about if it's like x to the second times plus x to the third? What do we do in this example? Because we don't have anything like that here. Well, if you'll remember, order of operations say that we need to do parentheses first, which there are none. We need to do exponents second. Before I can add these together, I would need to know x's so I could square it and I could cube it, and then I could finally add. But I can't add first. A lot of people seem to think that you're going to get x to the 5th, which is not correct. So we haven't really gone over that, but I did want to throw that out there just in case you were kind of wondering. Again, we're multiplying the bases here. We're not adding the bases. It's known as combining like terms. You can only combine like terms. So in this case, the answer to this is actually x squared plus x to the third. Now, if you're wondering, well, what if it was x to the third plus x to the third? Well, yeah, now we would have 2x to the third. The last little part that I threw in isn't super important to what it is that we're talking about, but I just wanted to throw that out there in case anyone had any questions. Exponents can be kind of a crazy thing. We just want to remember if we're adding, we're combining like terms, and if we're multiplying or dividing, we have these special rules.